This video is going to look at solving logarithmic equations. The thing you need to understand is that when solving logarithmic equations, they come in actually three types. The first type would be one where the unknown is the value on the opposite side of the log. A second type is where the unknown value is in the position next to the log. And the third type is when the unknown value is actually in the base position. So we'll take a look at each one of these. The first type of logarithmic equation is one where the unknown value to solve for is on the opposite side from the log. Now the first step that we're going to apply to all logarithmic equations is to actually change them back into exponential form. In this case, that would give us the new form 125, the base, raised to the power x equals the value 5, which now gives us an exponential equation. And using what we learned about solving exponential equations, we would now try to write both sides using the same base. Remembering that 125 does equal 5 to the third, we can write that side as 5 to the third raised to the x equals 5, which is to the first power. And then, using our laws of exponents, we can rewrite the left side as 5 raised to the 3x equals 5 to the first. And at this point, since the bases are now the same, we can drop the bases and we get ourselves a new equation, 3x equals 1, which when solved gives us x equals 1/3, the solution to the original logarithmic equation. So that's the first type. The second type of logarithmic equation is one where the unknown value, in this case x, is in the location next to the log. Much like with the previous type, we would start by writing this in exponential form, giving us 3 raised to the fourth equals 2x plus 7. And now, to go further, we would now take this 3 to the fourth and work that out. 3 to the fourth is 81, so we get 81 equals 2x plus 7. And now all we end up with is a little first degree equation, like from the beginning of the term. And solving this, let's see, we would now subtract 7 from both sides, giving us, in this case, 74 equals 2x. And then we'd go ahead and divide both sides by 2 to solve for x, giving us x equals 37. And that would be the solution to this original logarithmic equation. So that's what to do when the unknown is in the position next to the log. For our third example, we'll solve a logarithmic equation where the unknown is actually in the base position. Once again, the first step is to write this using exponential form. So we take the base x, now raised to the power 1/3 equals 4. But now we have a situation where we're trying to solve for the base. And to do this is going to be a little bit different than the other two. Not necessarily more difficult, just different. And our goal here is to think that we want to try and get this where we have x by itself on one side. And to do that, we would like x to actually have a power of 1 instead of what it is, a power of 1/3. And so to do that, using a simple power rule for exponents, we take that x to the 1/3, and I'm actually going to raise it to the power of 3, which is the reciprocal of 1/3, because when I do that, when I actually use the power rule to multiply these two together, what will end up happening is I'll get x, 3 times a third is 1, I get x to the first power, which again just gives me the x I was looking for. Of course, whatever you do to one side, you have to do to the other. So if I raise the x to the 1/3 to the third power, I've got to raise 4 also to the third power. And that just gives me a 64. And in the end, we don't need that 1 there. In the end, the answer is x equals 64. And so that's an example of what to do when the unknown is actually in the base position. So these different three logarithmic equations, we all start by putting in exponential form, and then depending on where the variable shows up is how we actually approach solving that problem.